This quick video is designed to help you apply the law of cosines. We're not going to spend time actually deriving it, so if I would encourage you, if you were not in class, to read page 301 to see how the law of cosines is derived. So as written on page 301, the law of cosines states that for any triangle with sides of length ABC, opposite angles with measures capital A, capital B, capital C, respectively. So that's the system we're going to use, where if we have triangle ABC, ABC, we're just going to let the opposite side have a length of the lowercase letter, whatever the angle is. And we're kind of fudging a little bit that the capital letter is actually going to represent and measure the angle. He didn't do that in geometry, but just to kind of save us from having to write measure of angle A, we're gonna use that system. So if we have this situation, and this is not necessarily a right triangle or an obtuse triangle or an acute triangle, it works for any triangle that, and you can see I've written it 3 times. Okay, so c squared would equal a squared plus b squared minus 2ab cosine of c. B squared would equal a squared plus c squared minus 2ac cosine of b times the cosine of b, and a squared would equal b squared plus c squared minus 2bc times the cosine of a. So the point being, it doesn't matter, whatever angle you're taking the cosine of over here, the side that's its opposite angle will be by itself over here being squared, and then everything else is made up of the other 2 sides. So that's why I write it 3 times, just so you're not thinking that it's one particular angle of the triangle that we're taking for which we're taking the cosine. Let's go now to see how we can apply the law of cosines to solve some triangle problems that don't involve right triangles. In example 1 here, we see that we have a triangle where we know 2 of the side lengths. One is 7, that should be centimeters. The other is 9 centimeters. And we know the measure of the angle between them. And we should, by using the law of cosines, be able to figure out what the third side length is here. See if you can write an equation using our law of cosines that involves all 4 of these measures. And if you can do that, then you should be able to solve for z. Go ahead and pause the video to do that. If you did your computation correctly, you should have ended up with z equal to 15, oops, I need my pen here, 15.051 centimeters. And I'm going to encourage you to carry your units out to 3 decimal places. This is actually an AP rule, so we might as well get used to it. Alright, by the way, that's a 0 right there. Okay, so if you had trouble getting this, go back and see if maybe you made a mistake, but I'm going to go ahead and do the derivation with you. But if you want to pause the video and try to find your mistake yourself, that would be even better. Alright, well, in writing the equation from the law of cosines, of course we only have one place to put an angle, and then 3 spots to fill in the sides. So since we were given the measure of an angle, then obviously, pretty obviously, we're going to have the cosine of 140 degrees way out here. Okay. Now the question is, what side length do you fill in, do you square over here by itself? And we mentioned very briefly that whatever your angle is in the law of cosines here, the side by itself that gets squared is going to be the one opposite the angle. So we would just go ahead and say that this is z squared here, and then everything else in the law of cosines is made up of the other 2 sides. Okay, and it's just the Pythagorean theorem, so we would just take 7 squared plus 9 squared, and then you have to subtract 2 times the 7 times the 9 times the cosine of 140 degrees. And it's pretty much laid out for you right there. I mean, you can just plug this straight into your calculator. Make sure when you do the 100, cosine 140 degrees that you are either in degree mode or that you use that degree symbol. I would say it's best to go ahead and do your settings on the calculator in degree mode. I think we talked about that in the previous lesson. So if you plug things in correctly, you should end up with z squared equal to 226.521 dot dot dot. It's actually going to be a big, probably 10 decimal number in your calculator. Just keep that accuracy there. If students make any mistake on this computation, it's usually that they stop right here. They think they're done, but of course 226 would definitely be way too big for this triangle here, and indeed we do need to make sure we take the square root of it to figure out what z is, and that is how we will get 15.051 centimeters. Alright, let's take a look at another example. Here is example 2, and you can see it's a little different. Instead of being given an angle, we are given all three sides of the triangle, and we're being asked to solve for angle y. So see what you can do with that. Try to set up your equation again. This time you're trying to solve for the angle, and see how you do with that. This situation is maybe a little more complicated than the other one. In fact, I'll mention there is kind of a trap that students fall into with this. If you find that your calculator gives you an error when you try to compute for the angle, that probably means you fell into the trap. Pause the video and see how you do with this. Okay, well, if you did this computation correctly, you should have ended up with angle y being 41, whoops, I need my pen, being 41.171 degrees. Alright, if you did not get that, go back and check. Now, also you want to make sure that you are in degree mode so that when you do like the inverse cosine, I think that's going to be required here, you will end up with a degree measure. So that would be something to check too. Alright, so go back and look and see if you can find your mistake, and then come back to the video, and I'm going to do it here like I did the last one. Alright, so this time now we are solving for an angle, so that means we need to make sure that angle y is in our equation. So I'm going to have the cosine of y over here by itself, and that means that the side length that gets squared by itself is going to be the 9, right? The one opposite that. And now I just fill in the rest of this with the other two side lengths, so we would have 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of y. And now we need to solve for y. But you need to remember, before we solve for y, the step that comes before that, okay, we're going to have y equals in the end. But before we have that, we need to figure out what the cosine of y equals. So essentially, let's break it down into two things we're solving for. First, we need to solve for the cosine of y. Alright, think of that as your variable. If you want to replace that with, a big x or something, say, okay, I'm going to solve for x first. Alright, and so we would need to, let's see, we'll square all these numbers, and we need to just start getting rid of things. And first of all, we will subtract the 7 squared over and the 13 squared over. So I'm going to do that. Let's see. So if I take 9 squared, let me kind of point to it. If I take 9 squared and subtract 7 squared and then 13 squared from it, that is going to give me negative 137. I'm kind of running out of room, so that's why I'm describing things and not writing everything out. And then I also have the negative 2 times the 7 times the 13 times the cosine of y. So if we multiply those together, we will have negative 182 times the cosine of y. Now, it's possible that you might have not gotten this line if you fell into the trap. The mistake I see a lot of students make on this is they will take all of these numbers right here, the 7 squared plus 13 squared minus 2 times 7 times 13, and they will combine all of those and have that multiply in the cosine of y and say that's equal to 81. And that's just not that's not good algebra, right? Let's think about it. That would be the same as saying that, that say 2 squared plus 3 squared minus, 2 times 3 times x. Okay, let's see, 2 squared plus 3 squared, that's 4 plus 9 is 13. So that'd be like 13 minus 6x. Now, is 13 minus 6x going to give us 7x? Would we be able to combine those two terms? And you know very well that that's not correct, right? These are unlike terms. The 13 and the 6x are not the same. Now, 13x minus 6x gives us 7x, but not 13 minus 6x. So we cannot do this. This is not right, okay? And that's why it wouldn't be right to combine all of these terms here, all the numbers here, and have them multiply by cosine. So we bring the 7 squared over, the 13 squared over to the other side of the equal sign, and then we combine these terms times the cosine of y. All right, and now we're going to divide both sides by negative 182, and that will give us positive, right, 0.7527 dot dot dot, and then we take the inverse cosine of that and we get 41.171 degrees. Before we conclude this video, I just want to point out a couple of things about the law of cosines here. Of course, there's all three side measures are in the law of cosines, and only one angle measure is in it. So that means we have a total of four pieces, that go into the law of cosines, or 4 variables, I guess if you want to say it. So we need to be given 3 of those and be left with just one of them to solve. So that means we need at least 2 side lengths to be given to be able to use the law of cosines. And then, perhaps we might be given the angle, one of the angles, or given the third side length. So if we look back at example 1, we can see there we were given the SAS situation. And the law of cosines is just really well suited to deal with this situation, right? Where you're given 2 side lengths and the angle between them, because we saw it was very easy to solve for that third side. Now, the other possible thing that we could be given as far as 2 sides and an angle, if you recall with your geometry, would be SSA. Whoops. We're going to see that SSA, there's probably a better way to deal with the SSA situation, but we could use the law of cosines on this. I don't believe you're going to have any problems on the homework where you need to do that. So we're not going to worry about that situation right now, but we will come back to it. You might recall from geometry that SSA was one of the situations that actually did not lead to triangle congruence. It's one of those, it's a kind of a special case that seems like it would work, but it doesn't always work. Example 2, as you might recall, involved all 3 sides of the triangle. So of course that's the SSS situation, and we saw that the law of cosines deals with that situation pretty well. Unfortunately, we can only solve for one angle at a time, but if you had to solve for the other 2 angles, once we found angle y, you could do it one more time to get the second angle, and then of course for the third angle, we know that the sum of the angles is going to be 180 degrees, so not too bad of a situation there. Alright, so I think this is enough that you should be able to handle the homework assignment that's on the Sanford Hub website, and best of luck to you. We'll see you in class.